Okay, hi everyone, welcome back to this video series on Windows Server 2016 using Get Help. How many hundreds of times have you used the / switch in command prompt to pull some extra information about a command that you want to run? The extra information provided by this help function can sometimes mean the difference between a command being useful or completely useless. PowerShell cmdlets have a similar function, but you cannot simply type / question mark at the end of a PowerShell cmdlet, because a space following a cmdlet in PowerShell indicates that you are about to specify a parameter to be used with that cmdlet. For example, if we try to use / question mark with the restart computer cmdlet in order to find more information about how to use our restart computer, it will fail to recognize the question mark as a valid parameter, and our output is as follows. Instead, there is an even more powerful help function inside PowerShell. GetHelp is a cmdlet, and like any cmdlet, we need to use information following the cmdlet in order to specify and pull the information that we are looking for. So instead of using get help at the end of a command like we used to do with the question mark, we use it as its own entity. Running a get help by itself only gives us more information about the get help window. Sorry, the get help command, which may be useful to look over, but right now we are more interested in finding out how we can use get help to give us additional information for a cmdlet we want to run, such as the restart computer function. What we need to do is use get help as a cmdlet and then specify the other cmdlet as a parameter to pass to get help by placing a space between them. Formatting the output. When searching for information in PowerShell, I often encounter the case where so much information is provided to me that it's difficult to sort through. Are you trying to find useful cmdlets from get command, or maybe track down a particular alias with get alias? The output from these cmdlets can be staggeringly long. While we have discussed some parameters you can use to whittle down this output, like specifying particular name parameters, there are a couple of formatting parameters that can also be appended to cmdlets in order to modify the data output. Format table. The purpose of format table is pretty simple. It takes the data output from a command and puts it into a table format. This generally makes the information much easier to read and work with. Let's look at an example. We have used getNet IP address a couple of times, but let's be honest, its output is a little messy. Running the cmdlet by itself on my virtual server, which only has a single NIC assigned to it, results in 6 pages of data inside my PowerShell window. If I simply add format table to my getNet IP address cmdlet, the generated data is much easier on the eyes, while still giving me the important information that I'm really looking for, the IP addresses being used on the system. GetNet IP address format table. Some of you may be familiar with a cmdlet called select object, which can perform the same functions as format table. While select object seems to be more widely known cmdlet, in my experience, it is actually less powerful than format table, format list. Similar to the way that format tables work, you can utilize format list in order to display command output as a list of properties. Let's give it a quick try. We already know that get command gives us the available cmdlets within PowerShell, And by default, it gives them to us in a table format. If we want to view that output in a list instead, with more information being provided about each CMDlet, we could tell get command to output its data in a list format instead. Get command format list. And we can hone that down even further by telling PowerShell we would like to see a list of all CMDlets, including the word restart, and see them in list format. PowerShell integrated scripting environment. Most server administrators are familiar with the concept of creating batch files for use in the command prompt word. Have a series of commands that you want to run in sequence. Need to run this sequence of commands multiple times across different servers or over and over again in the future. Throwing multiple commands inside a text document and then saving it with the file extension .bat will result in a batch file that can be run on any Windows computer. Issuing those commands in sequence, which saves you time and effort of having to plunk out these commands over and over. Instead, the command line interface scripting in PowerShell is the same idea but more powerful. Commands in command prompt are useful but limited, while PowerShell CMDlets have the ability to manipulate anything within the operating system. With PowerShell, we also have the ability to reference items from inside environment variables or the registry. We can easily issue commands to remote systems, and we can even utilize variables inside a PowerShell script, just like you would do with any full programming language. Let's explore a couple of different ways that can be used to start creating your first PowerShell scripts. PS1 file. Creating a PS1 file, a PowerShell script file, is almost exactly the same idea as creating a .bat file. All you have to do is open up a text document using your favorite editor, throw in a series of commands or CMDlets, and then save the file as filename.ps1. As long as your PowerShell environment allows the running of scripts, you now have the ability to double click on that PS1 file or launch it from any PowerShell or prompt to run a series of CMDlets inside that script. Let's give it a try and prove that we can get a simple script up and operational. Since you are only going to create scripts that serve a purpose, let's think of a real world example. I work with terminal servers quite a bit, RDS servers, and a common request from customers is to log of what users logged into which servers. A simple way to gather this information is to create a logon script that records information about the user session to a file as they are logging in. In order to do this, I need to create a script that I can continue to run during the logon process. To make the script a little bit more interesting and flexible down the road, I'm going to utilize some variables for my username, the current date and time, and record the name of the RDS server being logged into. That way I can look at the collective set of logs down the road and easily sort between which users were on which servers. I'm going to use Notepad for creating this script. I've opened up a new instance of Notepad, entered in the following commands, and I'm now going to save this as C scripts user reporting.ps1. $user equals $env username, $RDSH equals $env computer name, $date equals get date, echo $user $user $date $RDSH output file C scripts reporting.text append. If I run this script a few times, I can open up my reporting.txt file to see that it is logging the information that I specified each time I run the script. Integrated scripting environment. If I'm being honest, putting together that simple little script we just took a few tries. I didn't have a copy of it readily available to copy from, and I needed to test a couple of the lines individually in PowerShell before I was confident they would work in my script. I also first tried to pull the username without using the environment variable, and it didn't work. Why did I have so much trouble in putting together just those few simple lines of code? Because as I type those lines in Notepad, I have absolutely no idea whether or not they are going to work. When I save and try to run that script, all of the text is just black with a white background, and I am fully trusting my own knowledge and scripting abilities in order to put together something that actually works. Thankfully, we have access to the PowerShell integrated scripting environment, ISE. This is a program that is installed by default in Windows Server 2016. It is a scripting shell that allows you to write PowerShell scripts and helps you along the way. Let's go ahead, open it. If you right click on the PowerShell icon itself, you will find an option to launch Windows PowerShell ISE right from the menu. Now, if we go ahead and start typing in the same script information that I used in Notepad a few minutes ago, you can see that even as we type, we get pop-ups and prompts that help us decide which CMDlets or variables we want to utilize, similar to the way that our auto prompt keyboards on our smartphones work. ISE will give suggestions about what it is you are starting to type so that you don't necessarily have to remember what the CMDlets or parameters are called. You can take an educated guess on what letter it starts with and then choose one from the list that is presented. There is also a list off to the right of all the commands available, and it is searchable. That is a great feature that really helps to get these scripts rolling. Also useful is the blue PowerShell mini screen that consumes the bottom half of the development window inside ISE. Basically, what happens is that you type in some commands in the above space. ISE helps you to make sure they are going to work by color coding the CMDlets and parameters for easy identification. And then you click on the green arrow button in the above taskbar that is labeled Run Script. Even if you haven't saved your script anywhere yet, ISE launches through your commands and presents the output in the below PowerShell prompt window. This allows you to test your script or test changes that you are making to an existing script without having to save the file and then launch it separately from an actual PowerShell window. Remotely managing the server. Now that we have worked a little bit in the local instance of PowerShell and have explored a couple of methods that can be used to start creating scripts, it is time to take a closer look at how PowerShell fits into your centralized administration needs. If you start using PowerShell for server administration, but are still RDPing into the servers and then opening PowerShell from there, you're doing it wrong. We already know that you can tap remote servers into Server Manager so they can be managed centrally. And we also know that the tools inside Server Manager are, for the most part, just issuing a series of PowerShell CMDlets when you click on the buttons. Combine these two pieces of information and you can summarize that PowerShell commands and CMDlets can be easily run against remote systems, ones that you are not currently logged into. Taking this idea and running it, we are going to look over the criteria that are necessary to make this happen in your own environment. We are going to make sure that one of our servers is ready to accept remote PowerShell connections, and then use a PowerShell prompt on a different machine in order to pull information and make changes on that remote server, preparing the remote server. There are just a couple of items that need to be running and enabled on your remote servers in order for you to tap PowerShell into them from a different machine. If all of your servers are Windows Server 2016, in fact, if they are all Windows Server 2012 or higher, then PowerShell remoting is enabled by default, and you'll be able to skip the next couple of sections here. However, if you try to use PowerShell remoting and it's not working for you, it is important that you understand how it works under the hood. This way you can troubleshoot it and manually establish remote capabilities in the event that you run into problems or are running some older operating systems, which these steps may be necessary. WinRM service. One piece of the remote management puzzle is the WinRM service, simply making sure that this service is running. If you have stopped it at some sort of hardening or security benefit, you will need to reverse that change and get the service back up and running in order to use PowerShell remoting. You can check the status of the WinRM service from services.msc, of course, or since we are using PowerShell in this chapter, you could check it with the following command: get service WinRM. Enabling PS remoting. Typically, the only other thing that needs to be accomplished on your remote server is to run a single CMD-let. Well, it needs to have network access, of course, or you won't be able to see it on the network at all. But other than making sure network connectivity and flow are working directly from the console on your new server, you are then ready to issue the PowerShell command that enables this server to be able to accept incoming remote PowerShell connections. Enable-PS remoting force. Using force at the end of the Enable-PSRemoting command causes the command to roll without asking you for confirmations. There are a few different things that Enable-PSRemoting is doing in the background here. It is attempting to start the WinRM service. Then why did I already specify that you should check it manually? Because if you have it disabled as part of a lockdown strategy, you will interfere with the process. Checking WinRM before using Enable-PSRemoting increases your chances of success when running the Enable-PSRemoting CMD-let. There are two other things that this command is also doing: starting the listener for remote connections and creating a firewall rule on the system to allow this traffic to pass successfully. If you intend to use PowerShell remoting on a large scale, it is a daunting thing to think about logging into every single server and running this command. Thankfully, you don't have to. As with most functions in the Windows world, we can use group policy to make this change for us automatically. Create a new GPO, link and filter it appropriately so that it only applies to those servers which you want to be centrally managed, and then configure the settings: computer configuration policies, administrative templates, Windows components, Windows remote management, WinRM service. Set allow remote server management through WinRM to enabled. Allowing machines from other domains or workgroups. If you are working with servers that are all part of the same corporate domain, which will most often be the case, then authentication between machines is easy to accomplish. They automatically trust each other at this level. However, on the server, you are prepping to accept remote connections. If you accept, those computers will be members of a different domain that is not trusted or even members of a workgroup. Then you will have to issue a command to manually trust the individual computers that are going to be connecting in. For example, if I am planning to manage all my servers from a client computer called Win10 client that is not trusted by the servers, then I would need to run the following command on these servers: set item wsman localhost client trusted hosts Win10 client. If you wanted to allow any machine to connect remotely, you could replace the individual computer with a asterisk, but in general, this would be a good practice, as you may be inviting trouble by allowing any machine to connect to you in this way. Connecting to the remote server, I typically see administrators utilize PowerShelling in two different ways. You can perform some commands against remote systems on an ad hoc basis while your PowerShell prompt is still local, or you can launch into a full-blown remote PowerShell session in order to make your PowerShell prompt behave as if it's running directly on that system. Let's take a look at both options using ComputerName. Many of the CMD-lets available in PowerShell, particularly ones that begin with get minus, are able to be used with the -ComputerName parameter. This specifies that the command you are about to run needs to execute against the remote system that you specify in the -ComputerName section. For our remote PowerShell examples, I will be using a PowerShell prompt on my Windows 10 client computer to access information on some of my servers in the network. Here you can see that from my standard PowerShell prompt, I can query a service on my Web1 server using the following command: get -service WinRM -ComputerName Web1. Alternatively, perhaps I want to see all of the roles currently installed on Web1. Get -Windows feature -ComputerName Web1 where installed. The -ComputerName parameter can even accept multiple server names at the same time. If I wanted to check the status of the WinRM service or on a few of my servers by using a single command, I could do something like this: get -service WinRM -ComputerName Web1 Web2 DC1 using Enter-PSSession. On the other hand, sometimes you have different CMD-lets that you want to run against a particular server. In this case, it makes more sense to invoke the fully capable, fully remote PowerShell instance to that remote server. If you open up PowerShell on your local system and utilize the Enter-PSSession CMD-let, your PowerShell prompt will be a full remote representation of PowerShell on that remote server. You are then able to issue commands in that prompt, and they will execute as if you were sitting at a PowerShell prompt from a console on that server. Once again, I'm logged into my Windows 10 client computer and have opened up PowerShell. I then use the following command to remotely connect to my Web1 server: enter -PSSession -ComputerName Web1. You will see the prompt change indicating that I'm now working in the context of Web1 server. Tip: if your user account does not have access to the server, you can specify alternate credentials to be used when creating this remote connection. Simply append your Enter-PSSession CMD-let with -credential username in order to specify a different user account. Commands that I issue from this point forward will be executed against Web1. Let's verify this. If I check a simple $ENV computer name, you can see that it presents me with the Web1 hostname. And to further verify this, if I check the installed Windows roles and features, you can see that I have the web server role installed, as well as failover clustering from earlier in the book. These are clearly items that are not installed on my Windows 10 machine. PowerShell is pulling this data from the Web1 server get Windows feature when installed. This is pretty powerful stuff. We are sitting at our local desktop computer, have a remote PowerShell session running to the Web1 server, and are now able to pull all kinds of information from Web1. Because it is as if we are working from PowerShell right on that server, let's take it one step further and try to make a configuration change on Web1. Just to verify that we can, maybe we can install a new feature onto this server. I use Telnet client quite a bit, but can see that it is currently not installed on Web1. Get Windows feature -name Telnet. By using the add Windows feature CMD-let, I should be able to make quick work of installing that feature. Add -Windows feature Telnet -client, testing it with server core and Nano core, so that all this works while interacting with real servers that are running the full desktop experience operating system, as we have seen with the Web1 server. But what about my server instances running server core or Nano core? This process is exactly the same. PowerShell is integral to the way that Windows Server 2016 is built and allows streamlined functionality and access across all instances of its platform. If my Web1 server has been a server core or a Nano server, I would have been able to interface with it the same way I just did. We will run a quick test to verify this. I do have my Core 1 server up and running at the moment, so let's establish a remote PowerShell session to Core 1 and verify that it also outputs us with the information from the Core 1 server. Enter -PSSession computer name Core 1 $ENV computer name. As you can see, we are now remoted into the PowerShell interface of the Core 1 server and can manipulate that server in any way that we could with a full-blown desktop experience server. PowerShell remoting will likely be the most common way that you interact with server, core, and Nano server instances, so definitely make these tools part of your daily arsenal. Desired state configuration. There is some new and powerful functionality in PowerShell 5.0 provided by something called Desired State Configuration, DCS. DCS is a management platform plugged into PowerShell, which provides some new functions and CMD-lets that you can take advantage of in your scripts to enable some really cool features. As the name implies, it allows you to build configurations inside PowerShell that will provide a desired state. What do I mean by that? Well, in a basic sense, what DSC does is make sure that the PowerShell scripts you build will always work the same way across all of the servers where you apply them. It is quite easy to build a script in such a way that it will work correctly on the server you are currently working from. But if you try to roll that script out to a different server that might reside in a different OU, which is organizational unit, or have different items installed on it to begin with, that the script could produce different results than it was originally intended to. DSC was built to counteract these differences. In building your DSC configuration, you identify particular roles, settings, functions, accounts, variables, and so on, all of which you want to retain in your specified desired state. Once you identify and configure these variables, DSC will work to ensure they stay where you have them set and they remain uniform according to your DSC configuration policy, which means they are uniform against the other servers where you have run this script. DSC also helps to prevent unwanted changes on servers. If your DSC enabled script has identified that a particular service should be running all the time on your servers, and that service stops for some reason, DSC can be there to help you spin it back up so you don't experience an outage. Alternatively, perhaps you have a script that configures a server to a particular set of standards, and another person in the IT staff comes along and adjust the configuration on the server itself. Maybe they log in and stop the service purposefully for some reason. These are some of the situations where DSC can intervene and set the server back into a desired state in which you placed it originally. DSC is your scripting nanny, so to speak. It helps to build configurations that will remain uniform across multiple platforms and will then work to ensure these configurations are always true. You can be confident that your servers are always running within the context of your specified desired state. After building your configuration that identifies the items you want to be installed or monitored, something called the Local Configuration Manager, LCM, works to ensure the resources remain within the configuration specification. LCM polls the system, regularly watching for irregularities and changes, and takes action when needed to bring your server back into the desired state configuration. The ultimate goal of DSC is to keep everything constant and consistent across your servers and services. DSC's capabilities and access to reach into more and more places in the operating system grows constantly as roles are rewritten to accept DSC parameters and monitoring. In the end, I believe it'll be Microsoft's goal that every server runs a DSC configuration script, ensuring that it is constantly working within your standards and helping to maintain your 99.999% uptime status. Summary. In Windows Server 2016, we see in multiple places that administration via PowerShell is the recommended path to interacting with our service. The fact that the management GUIs are just shells are running PowerShell scripts, and that the default installation option for Windows Server is Server Core, we can assume the headless command line orientated servers are going to be our servers of the future, even though PowerShell really has been at the core of our operating system functionality since Server 2012. Until this point, I believe that PowerShell has been viewed by most admins as simply an alternative way of managing servers. Yeah, I know that it exists and I should start using it, and scripting looks pretty cool, but I can still do anything I want with the old command prompt or my mouse button. That old mentality is quickly changing. Now that we are experiencing the onset of new technologies such as DSC, we can see that PowerShell is starting to develop functionality that simply does not exist anywhere else in the operating system. This, combined with the remote management accessibility provided by the standardized PowerShell platform that can be used across all of your current Windows devices, means that we will definitely be seeing more and more PowerShell in subsequent Microsoft operating systems and services. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.